Hi everyone. Today we'll talk about one of the very exciting topic, quantum computing. Although it is hard to understand without the knowledge of quantum physics, but I'll try to simplify and explain. So let's get started. So what is quantum computer? A quantum computer is a machine that performs calculation based on the laws of quantum mechanics, which is the behavior of particles at the subatomic level. The 19th century was known as the machine age. The 20th century will go down in the history as the information age, and I believe the 21st century will be the quantum age. This is the saying from Paul Davies. So when we say quantum, it means very small, and we have seen that number of transistors which was there in processor in 1970 was 4004, and you can see every year it is increasing. Means the processor is getting smaller and smaller. And right now it is more than a billion or million processors in Pentium processors. Allowing computers to take advantage of quantum mechanical behavior allows us to do more than just simple small things. It gives us a whole new framework in which the information can be processed in a fundamentally new ways. So this is not a faster processing with old theory. This is new theory as well. So what is this new theory? So rather than storing the information using bits represented by 0 or 1, as the conventional digital computers do, quantum computers use quantum bits, or we call it qubits. Qubits help us to encode information as 0 and 1 or both at the same time. Now this is the difference. Like in case of classical computing, it is in the state of 0 or 1 at a time, but in qubits it can be both. This superposition of states, along with the other quantum mechanical phenomena of entanglement and tunneling, enable quantum computers to manipulate enormous combination of state at once. So how we represent data in quantum computers? So quantum computers which have not been built yet would be based on the strange principle of quantum mechanics, in which the smallest particle of light and matter can be in different processes at the same time. In a quantum computer, one qubit quantum bit could be both 0 and 1 at the same time. So with 3 qubits of data, a quantum computer could store all 8 combinations of 0 and 1 simultaneously. This means a 3 qubits quantum computers could calculate 8 times faster than a 3-bit digital computer. A typical personal computer today calculates 64 bits of data at a time. A quantum computer with 64 qubits would be 2 to the power 64 times faster, or about 18 billion times faster. Here billion is very correct. So let's see, in case of classical bits, we have classical computer, we have 0 and 1, and it can have 1 out of 2 to n possible permutations. But in case of quantum bits, both 0 and 1 possible, and all of 2 to the power n possible permutation combination is also possible. To speed computation, quantum computers tap directly into the unimaginably very fast fabric of reality, the strange and counterintuitive world of quantum mechanics. While we are only at the beginning of this journey, quantum computing has been the potential to lead the breakthrough in science, business, and other domains as well. So let's see the difference between classical computing and quantum computing. In case of classical computing, we have seen that it calculates with transistors which can be 0 or 1. In case of quantum computing, it calculates with qubits which can represent 0 and 1 at the same time. In case of classical computing, power increases at 1:1 relationship with the number of transistors. In case of quantum computing, power increases exponentially in proportion to the number of qubits. Quantum computers have high error rates and need to be kept ultra cold. Classical computers have low error rates and can operate at room temperature. Quantum computer is well suited for tasks like optimization problems, data analysis, and simulations, whereas classical computing is suitable for almost everyday processing of data. In case of classical computers, where the calculation happen with transistors, not qubits. In In case of classical computers, we use transistors which makes up a basic logical gates. In case of quantum computers, multiple qubits make up a logical qubits. Now, what is the quantum computing timeline? So, how the journey is evolved till now. Quantum computing first theorized by Paul Winoff in 1981. In 1994, discovery of source algorithm for integer factorization happened. The first working of qubit quantum computer demonstrated in 1998. In 2001, first execution of source algorithm happened. In 2005, first quantum byte created by scientists at Innsbruck, Austria, and in 2017, IBM successfully tested 16 qubits quantum computers. So there's a lot of improvement happened in case of quantum computing, and all the major technology providers such as Google and others are trying to explore more options on quantum computing. Now, what are the top ways in which quantum computing is going to impact us? First is high frequency trading. Second, it can help in fraud detection. Quantum computing can also help in development of complex quantum algorithm. It can also help in portfolio optimization and security and risk assessment. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.